Hi. So today we are looking into the concept of how to find the units of the rate constant. Okay. So what we are trying to find out actually the units of the rate constant for different order of reactions. So let's begin with first consider that order of reaction is 0. Okay, order of reaction is 0. So how we can write if it is order of reaction is 0? So we can write the rate expression or rate equation, that's K, that is the rate constant, into the concentration of the reactant raised to 0. It simply means that it is independent of the concentration of reactants. It does not depend, the rate is not dependent on the concentration of reactant. That we have already seen. That means it is a 0 order reaction. Okay. So let's find out what will be the K, units of K. So anything raised to 0 is always 1. So we can say that rate is equal to K in terms of the unit or dimensions. So what are the units of the rate that we have seen right at the beginning? It simply means concentration upon time. So the units of K will be concentration upon time. So what is the concentration? Moles dm cube upon time, seconds. That's all. So these are going to be the units for the 0 order reaction. Okay. So let's calculate for order of reaction is 1. Simple. Order of reaction, assume it is 1. So how to write the rate expression? Simple. Rate is equal to K into A, concentration of A raised to 1. Okay, either you don't write it, still it will be assumed that it is raised to 1. Okay, so now let's try to compute what will be the units of K. Rate as usual, irrespective, because it is as by definition, its units are fixed. Moles dm cube second raised to 1. K dimensions or units we are trying to find out. What about the concentration? Concentration, as we know, simple, it is moles. Okay, so this part is common on both the sides. So let's strike it out. And what you will be left is simple. Therefore, for first order reaction, K units would be S raised to minus 1. Straightforward. Hope this is clear. Okay. It is so simple. Order of reaction, if it is 1, the units of K, that is the rate constant, will be just S raised to seconds raised to minus 1, or 1 upon seconds, or 1 upon time. Okay. Now let's go into the next one. Let me rub this out. And let's say order of reaction is 2. So we can straightway write R rate is equal to K, and now is raised to 2 because this is the order of reaction 2. Okay, so rate units are fixed, that is moles dm cube raised to minus 3 second raised to minus 1 K, and let's put it, it would be like moles dm cube square. So let's further simplify. K, this will be moles square, and this will be dm minus 6, and this is moles dm minus 3 s minus 1. Tell me now, let's try to cancel it out. Okay, proper this one. So this mole and 1 dm cube. Okay, so we can say this will be, how we can write. So if this comes here in the as a denominator, so let's try to put it. K is equal to dm raised to minus 3 s raised to minus 1 divided by mole and dm raised to minus 6. So what we will get, what you rightly guess, it would be moles raised to minus 1. This would be, this minus 6 will come into the numerator. You are quite familiar with the indices, simple, and this stays like this. Okay, so this is going to be the rate constant dimensions. Okay, simple, extremely simple. We are just playing with the simple numbers. I think you are getting it, but let's do one more. Order of reaction is 3. Straightforward, do it mechanically now. We don't need to do anything. What is rate? This one, that is moles dm cube s raised to minus 1. What is K into moles dm cube raised to 3. So let's try to simplify. Moles dm cube s minus 1 K moles cube and dm raised to minus 9. So what will be K dimension? So this moles goes, this is 2, and if it comes on the other side, okay, so let's do it. Dm raised to cube s minus, okay, mole square comes into the denominator, dm raised to minus 9. And what you have correctly guessed, the dimensions are moles raised to minus 2, dm raised to 6, and seconds. As simple as that. Okay, so I think we have done enough practice of this. You people have got a good feedback, okay, a good feel of this, okay, so you can practice on this.